Okay, so we're gonna do we're gonna actually do the proof for the last example. Write the 2-column proof. Now, you can just write statements and make 2 columns for the statement and the reason, or you can just make you can draw out your 2-column proof. Okay, so then let's look at this. GR is congruent to IL. So GR, this whole thing, is congruent to this whole thing. SR, this short one, is congruent to SL. I have to prove that GS is congruent to IS. Now, I'm not going to mark that yet, right? Because I have to prove it. It's not true yet until I'm done with my proof. Okay, so my statements. Let's do like that. And then, so here are my statements. Here are my reasons. Step 1. Use different color. GR is congruent to IL, and SR is congruent to SL. The reason is that it's given. Step 2. Now, look at this again. Whenever you deal with whole segments with its parts, okay, we're going to use segment addition postulate. Okay, so you want to try to break it up into its parts. So GR equals GS plus SR. And IL equals, I'm just doing this to both segments. IL equals IS plus SL, right? 2, this is segment addition postulates. Now, before I go on, notice how step 1, I have congruent signs, and step 2, I have equal signs. For segment addition postulate, I have to make it equal, okay, not congruent. So I need to, if I want to move, if I want to go on any further using GR and IL or anything else, I need to change my step 1 to equal signs. So I could have done that for step 2 and then for step 3 do the segment addition postulate, but as long as you get it done, as long as you do it before you use it, it's fine. So then my step 3, I'm going to write GR equals IL and SR equals SL. And then since all I did was make it from congruent to equal, its definition of congruent segments. Okay. Then my next step, see how GR is right there, and then IL is right there. So then I can use this kind of as my equation and then substitute in the parts of GR, all of this, right? Because that equals GR. So I can substitute all of that into GR and then substitute all of this for IL. Okay? So I'm going to make GS plus SR equals IS plus SL. Again, all we did was substitute in all this stuff for GR and substitute in all this for IL. And that is substitution of congruent segments, new of equality because it's equal. Then my step 5, since I know that, well, from here, let's go back to our proof statement. GS is congruent to IS. Here's GS, here's IS. So somehow I have to get rid of SR and SL. Luckily, I know that they equal each other. So I can substitute in one for the other. So GS plus, it doesn't matter which one. I can change this to SL, or I can change this one to SR. So let me just change this to SL equals IS plus SL. Okay, so step 5, I'm running out of room here. I use substitution property. Remember not to write SUB for substitution because that can be subtraction property too. Okay, and then step 6. So for me to get rid of SL and SL, I just have to subtract it, right? So if I subtract, then I just get GS equal to IS. And that is subtraction property of equality. Now I'm almost done. Right here, even though I have GS equal IS and this is GS congruent to IS, I have to make it look exactly the same. So my last step I'm going to do is GS congruent to IS, and that step is definition of congruent segments. Okay, and that's it. We proved that GS is congruent to IS. Okay, remember we use segment addition postulate because I have this whole segment and then I need to use these parts, right? So parts to the whole, use segment addition postulate. Okay. So if you want, you can try to erase it or try not to look at this and try working on this proof yourself. Okay, just go back, rewind it or whatever, and then just try to work on the proof on your own, and then you can come back to this and check your answers. Okay. Okay. Well, that's it for this lesson. We'll see you. We'll see you for the next lesson. Okay. Thank you for watching Educator.com.